Hello, welcome to this lesson on solubility rules. The question of the day, what are some substances you know dissolve in water, and what are some that you know that do not dissolve in water? Just because a substance has ionic bonds or because it's polar doesn't mean that it's necessarily going to dissolve in water. When something will dissolve in water, we use the term soluble to describe it, and when things are insoluble, they won't dissolve. Think of sand and salt. Salt definitely dissolves in water. You know that if you've ever been to the beach. But sand does not. If you put sand in water, it will sink down to the bottom of the container, and that's because sand is insoluble. There are some ions that love to dissolve all the time, and they're listed here. All of the group 1 ions love to dissolve. Whatever they are bonded to, once they meet water, they break apart. They dissociate immediately. So that's going to be lithium, sodium, potassium, all your group 1 ions. Ammonium also loves to dissolve, NH4. Nitrates love to dissolve with no exceptions. Anything that they are bonded to, they will dissociate from. The same is true for acetate, hydrogen carbonate, and chlorate ions. There are some things that dissolve just some of the time, so it will depend on what they're bonded to. If you have a halide ion, meaning fluoride, chloride, bromide, or iodide, they will dissolve unless they're bonded to a silver, a mercury, or a lead ion. These particular ions prevent the halides from dissolving. Sulfates will usually dissolve unless they're bonded to silver, mercury, lead, calcium, strontium, or barium ions. So these 6 ions will prevent sulfate from dissolving. The thing is that the halides and the sulfates dissolve most of the time. That's why we speak about them as being soluble with some exceptions. Now, these ions don't like to dissolve, but they will if they're bonded to particular things. Compounds containing carbonate, phosphate, sulfide, chromate, and hydroxide usually don't like to dissolve, but they will dissolve if they are bonded to group 1 ions or ammonium ions, or if they are bonded to magnesium and calcium in the case of chromate, and calcium, strontium, and barium in the case of hydroxide. So again, these ions really don't like to dissolve. They like to stay bonded to whatever ion they are bonded to, but if they are bonded to these positive ions listed here, then they actually will dissolve. The amount of memorization that you'll need for these will depend on your teacher. I don't think that this is something worthwhile to keep in your head. The group 1 ions in ammonium, I think, are pretty good because they're always insoluble with no exceptions ever, no matter who they're bonded to, even these ions that don't really like to dissolve. So maybe just memorize those. Again, this is going to come down to your teacher and what they prefer for you to memorize. I know when I was a student, I was asked to memorize the solubility rules. I think many of us are beyond that. So this is just a decent representation. If you are learning this in New York State, I think the New York State reference tables showcase this pretty well. If you are not learning the New York State chemistry curriculum, I still think it's a pretty good table. Let me show you. This is the New York State reference table for solubility rules, and I think it's actually really good. So you have to look at it as if it's 2 separate tables here. These are things that do like to dissolve on the left, and the things that don't like to dissolve are on the right. Now, these are the things that are going to dissolve all the time, no matter what. That is your group 1 ions, ammonium, nitrate, acetate, and hydrogen carbonate, along with chlorate. Notice that there are no exceptions in that section. The halides and the sulfates like to dissolve, but they won't if they are combined with these particular ions. On the right side, or the right table, we have things that don't like to dissolve unless they're bonded to these things, in which case they will dissolve. So in the years that I was teaching in New York State, I would have my students circle these inner 2 columns. And we always said that if the compound was found in the middle, in the circle, then that would mean that that compound was considered insoluble. If it's in the inner circle, it is insoluble. And if it's not in that inner circle, then it is soluble. It would love to dissolve. So anything bonded to sodium, obviously outside that circle, sodium chloride makes sense. But if I had, let's say, silver bromide, AgBr, that Ag will bring the compound into that inner circle, and therefore it will not dissolve. It's insoluble. Carbonates, let's say I had, I don't know, calcium carbonate. Calcium carbonate would fall into that inner circle because it's a carbonate, and the calcium does not pull it out of the circle. But if I had potassium carbonate with a group 1, then that carbonate would get pulled out of the circle, and then I would have potassium. So I think this is a really great table. You could just Google New York State Chemistry Reference Table. This is on page 2. I think it's a really great representation. And again, what you have to memorize is going to come down to your teacher's preference. If I were going to tell you something to memorize, it would be the group 1 ions. It would be ammonium, the nitrates. I would remember that the halides like to dissolve unless they're bonded to these particular ions. And then probably the hydroxides. Those would be the things that I would choose to memorize just based on what comes up. You also will probably just accidentally memorize these because of how often they come up. So again, this is the New York reference table. I think it's great. Sometimes things dissolve, other times they don't. In the next video, we will talk about amounts of things dissolving, which is a little bit of a different ballgame. So subscribe so you don't miss it. Leave any questions you have in the comment section below the video, and I'll see you in the next one. Bye.